Hello. Good morning, everybody. So this is the first time I made this talk, so I'm going to have a notebook with me. Okay. I need my notes. Something very interesting of this conference is that we got a list of questions that they wanted us to answer, and I never get that kind of conference. They always tell me, just come and tell me your story, right? And so I had to come and actually tell a different story. So it's the first time I do it. I haven't rehearsed, so I need a notebook. So just to put you in context, my name is David. You can call me David. I am from Spain, but I come from Sweden. This is a very common thing nowadays in Europe. We are from somewhere and come from somewhere else, try to speak 3 languages, and end up speaking European English, which is what I speak, which is having a very funny accent. I'm one of the founders of the Arduino platform. I'm actually the guy that drew the first board and helped with the software, maintained the website for 7 years, and I'm now the head of education of this project. The project that became a company, and I guess this is one of the reasons why I'm here. I started a successful company out of an open source project, so I'm kind of like an entrepreneur / innovator to some extent. The kind of things that we do is what you can see in this video. We look at how people use machines and how that interaction with machines could be empowered and made easier for people. This is our latest project. It's called Project Eslöv. Eslöv is the name of a village outside of Sweden, so we're following, outside of Malmö in Sweden, sorry. We're following the IKEA path of giving names of local places to our products. And it's mainly a communication protocol that allows you to connect smart devices to one another and make them show up automatically on the screen and build interactions between them without having to write a single line of code. So it's a very unique way of looking at how to interact with small electronics. This is a nice video. I wanted to make a different video where I was going to be destroying one circuit board and then plugging a new one on stage. But I didn't let me do it. So the idea is that you can build things interactively as you go in a very easy way. So I'm a trained engineer, and I'm a PhD candidate in interaction design. So I look at how people interact with machines, but what people don't know is that I have a past as a media artist. And when they were preparing this conference, they were sending me emails all the time about this video. This video is intentionally made crappy, okay? It's a video from my time as part of an art collective called Research and Development. And the work in this art collective was to stress the relationships between humans and machines, but bringing them to an extreme. And here we invented a religious order of monks that were traveling the world praising the goods of electricity. This was made in 2003. The funny thing is that when we made this performance, it was the exact same day that the whole East Coast of the United States went into a blackout because of a failure in the electricity grid. We hadn't planned for the failure in the grid, but it was funny. So the whole idea is that we were walking around with this monk robe, and this monk robe was tied up together with electromagnets in the back. You can see that in the pictures. And we were carrying a big battery on our stomach. When the battery was running out, the electromagnets were releasing each other, and the ropes will fall apart, and we will end up naked. And that's not really good being a monk. So we had to go around plugging ourselves to the wall to recharge the battery all the time. So doing things like this inspired me and my friends to do things like Arduino, to make tools so that anybody in the art world could make their own interactive performances. This was a lot of fun. And if you want to become a Buddhist monk walking around, let me know. I will give you some drawings. So if you can lower the volume of this video, please. It's a really cheerful video, but yeah. So this video is not from my work. This video is from work from somebody else. And this is a project that is based on using Arduino to build a knitting machine. You know, a machine that can produce fabrics and clothes. So I'm trying to answer the question, how does innovation occur when technology meets the arts? In this case, this guy, who is an artist that was working in a different collective called La La Lab before, went into making his own do-it-yourself knitting machine. The interesting thing is that he's pushing this thing to the next level. So after making the knitting machine, he realized people might be interested in making their own clothes. So now he's going to make a company that will allow you to create your clothes online and get them manufactured one by one for yourself. And well, this video is pretty long, and I will invite you to check it out later. He hacks the shop system. So he makes his own clothes, and then he goes to the mannequins in the stores and puts his own clothes to the mannequins. So he tries to sell his clothes to the normal stores. So here you see how he can build the clothes and so on. So this machine is built on an Arduino board. That's an interesting thing to me. Like, we made something that enables somebody else to build their own system. And since this is an OpenKnit project, you see it on the upper left corner if you want to look for a reference. And then he goes back and puts it back on the stores. I don't think he asked for permission to do this on the stores, but he did it regardless. So technology in arts can be used, art in technology can be used as an inspiration for test different possibilities, not just the technical possibilities, but also stressing social interaction, like in this case. So one can ask, as an artist, how can artists be creative with the help of technology? Well, we've seen these videos, and we've seen what you can do, like you can stress the way of thinking about, for example, religious cults, or build your own clothes, or reappropriation of materials, and so on. But we're going beyond that level now. There is a whole group of people doing what is called biohacking. They're looking at how to embed technology into their bodies. And this picture is from Johan Osterlund, which is a Swedish biohacker. And biohacking at this point consists in doing things like including NFC tags in your hand, so you could open doors or check in the bus, or embedding LED lights, like in this case, under the skin. So what we see here is that this is bringing us to think about a different relationship with technology. You know, there are some people that are ready to go beyond what we commonly understand as normal and bring in aspects that might be considered normal in the future. So there's when art becomes interesting in technology. It's like pushing the envelope, breaking the boundaries. So everybody says creativity is about thinking outside the box. This is really thinking inside the skin, which is one level beyond that. So technology is an enabler that helps others become magicians. So as an innovator, what is the best outcome from art and technology? This picture is from one of my workshops, where I invited my students, which are design students, to make their own Google Glass. Making your own Google Glass is just $100 away. You just need a small screen, some kind of interactive technology, and a lens in front of your eye. Of course, if you have a lot of money, you can make it look very cool and very slick. If you don't have that money, it's going to look big and clumsy, but it's still a lot of fun. And it takes one day. So in one day, you can make your own Google Glass. What is important is not the fact that you can make this Google Glass. What is important is that once you wear this Google Glass, the way you relate to people and the way you relate to your history and things you are stored in the Google Glass are different. All of a sudden, you can search for information you couldn't search for before. You get a lot of data accessible to you. So this brings in new behaviors and new ways to relate to one another. If I'm looking at one of you, I have to confess, I almost never forget a face. I always forget the names. If I have something like this that tells me, hey, this is Jonas. Oh, Jonas, how are you doing? You know, it will probably enhance my social relationship to people. I will don't look like a jerk every single time, even though it's not intentional. I just don't have memory for names. It's a problem that I have. So I would say good art, at least to me, gives me moments of enlightenment. It gives me the aha experience. You know, I look at something that I like. I cannot say if it's a painting or a sculpture. There's also a lot of things that I don't like. But then I get, emotional. If you tie up this to technology, this will give us new ways of understanding how we belong to something or how we relate to people. So when asked about what is a good success story of an artist looking at technology, I always like to use this one example. This is an art piece made by Daniel Palacios, who is a Spanish artist, and he made this piece in 2006 in a Barcelona art space called Hangar. And he came to a workshop on electronics. It was one of my first workshops on electronics ever made. And he was learning how to do sculptures, and he said, I want to make a kinetic sculpture. And this thing you see here is a kinetic sculpture. It's different every time you look at it. It's changing all the time. It's basically a 5 meters long rope rotating at super high speed, and it's giving you an illusion of being something solid. And the interesting thing is that technology allowed him to build this sculpture in an entirely different way how anybody thought it would look like, even to himself. And the sculpture was present at many different locations. So he built it in 1 week. And then this thing traveled the world. So to me, this is a success story. On the other hand, when looking at these projects, and some other speakers already spoke about it, you have to look at what is a failed story. But the good thing of looking at a failed story is not that it failed, is that you need to understand why it failed. So if you look at a story where an artist, for example, intervenes in a company, there's a lot of experiments like this one in the world, you should ask yourself, why did this fail? Did this fail because there was too much stress put on the technology, or did it fail because the relationship between the art world and the technology world didn't happen? And this is a very common thing. This picture is from a book from Jesper Juhl called Failure in Video Games. It's a very interesting book that I recommend you guys read. So, since I was invited here by Sonar Plus Dia, I want to show this picture because this picture is from a piece from Ryoichi Ikeda, who is, in my eyes, one of the best media artists in the world. And the first time I saw him in 2006 at the Sonar Festival with a piece that completely blew my mind. And this piece is one of the largest art piece I've seen in my life. It's like a 10 meters tall kind of thing. That is a projection of white and black lines that represent data on one side, and on the other side you see the whole data floating around, and you can imagine that the white lines are generated by the information that's floating at the other side of the screen. This is called the transfinite, or transfinite. I don't know how you say that word at all. So I have to ask a question to you guys. How do you perceive is a good relationship between art and technology? What would be a success story for you in art and technology? What would be a meaningful contribution? Like, would you like to have a flat screen on your refrigerator showing you paintings from Monet? That would be like art and technology for you? Or would it be something else? Because that's what we will have to invest in, or we'll have to look into in the future. To me, a really good example, and with this I will close my presentation, is the Japanese designer artist Maiwa Denki. That is very unknown in the Western world. He's pretty famous in Seoul. I don't know if you guys went to any of his events, but he's famous for, he does a technical exploration of very small mechanical devices, and then looks at them and replicates structures with them in really large sizes. You know what they say? If you make one piece, it's design. If you make a lot of them, it's art, right? It's like if you make a vase with certain material, it will be a design piece. If you make 100 of them and exhibit them in a gallery, then it will be an art piece. Well, this is what this guy does. He looks at the technical piece and looks at how to apply this technical piece in a lot of different places. He makes instruments, and then he runs concerts. And out of those concerts, he creates toys, and he sells the toys. And he goes back and forth in this creative circle of putting something on stage, and if it works on stage, it can probably fit in your pocket and makes a plastic toy out of it. So to me, this is a very interesting success story on how somebody is looking at how the world works nowadays, how technology works nowadays, and makes art to them make it into a successful technical and commercial success. So that's it. Thank you very much. I have to call Park on stage. Hello. Thank you. Oh, with chairs.
Yes.
Thank you.
So thank you so much for your inspiring speech.
Thank you.
And I think definitely they will have a lot of questions for you, especially about Arduino and yourself. So let me ask you 3 questions for you, and let me give some questions from our audiences. Firstly, we all believe that the successful reason of the key factor of Arduino is maybe the strong community. Would you let us know about how did you build these strong communities?
I would say, yeah, I think the word community is strongly misused and abused. What happened with Arduino is that we tried to create a tool that would work for our students. We had a very, it's what is called a user-centered design process. We knew our users very well. All of us have been working as teachers. All of us were somehow students as well. So we knew what all the others needed, and we tried to put together this compendium of needs, and that became a brief, informally, of a design piece that then became a circuit board. What we did is that we made it open source, and we said, we have no money to make this thing as a product. If you're interested, you can copy it. Here it is. And that created a lot of traction, and people started to say, like, oh, where can we discuss about how to improve it? And that's when we opened a forum and then created an online community, a Web 2.0 community. It was not intended from the beginning. And it set a standard on how open hardware communities will be built. There will be a design, and around that design there will be specifications and a forum where people could discuss about it, and so on and so forth. The difference is that we started 5 years before anybody else. So we were visionaries, and we were challenging the establishment, because people will typically sell these things for a lot of money, and we said, no, this has to cost the same thing as a textbook. And that was one of the key aspects. And community was built around that everything else was right. So if you build a very expensive product and try to build a community around it, then you don't have a community. You most likely have a user base and a customer base that will complain when things don't work.
But still, it seems like after starting the Arduino, you became more entrepreneur rather than artist. How do you consider yourself after Arduino?
Yeah, what happened is that after 5 years running the project, we had only earned around $100,000. So that's no success criteria for a company. You know, like 5 or 6 employees, 5 years, and $100,000, they don't really match. What we did with the money is that we invited everybody we knew to a party in New York. So instead of, and so we met at ITP, the School of the Arts, at NYU, and we invited our community of users, like the most active Japanese contributor, the most active Spanish-speaking contributor, people that were designing circuit boards around it, and we paid them a trip to New York, and we met there, and around the table we asked people, guys, how shall we continue? What shall we do now? And people more or less gave us their blessing. They said, we think you need to make a company so that you can support the development of this thing farther. And we said, okay, let's make a company. But then we were 5 people in 5 different countries. So that was an entirely different story. But again, we were kind of pushed into making this because, for good or for bad, society works this way. If you want to make something that moves money around, either you are United Nations or you have to make a company.
Right.
And then we learn about being a company the hard way. You know, when you have a company, you have to pay salaries every month, and people get kids and houses, and they change work, and so your mindset has to transform.
Then how is your plan to sustain your community and your company?
Well, I don't know if you heard about the latest developments of Arduino, but our idea is that all the intellectual property production we do is open source, and that will be kept inside some sort of a foundation. And that will be basically paid from the company. And the company will be making commercial products and keep the foundation so that the intellectual property is kind of safe from whatever happens to the company, can get grants and so on. It has taken a lot of time to make this move. There is a lot of other people that make this move in the software world mainly. So we believe it's the right way to go.
Thank you. And also myself, as a hardware startup company, Arduino was a big successful factor for us to get into the real business. But there are many startups, but still it needs a lot of innovation to grow up, get onto the right track. How do you see the real innovative factor from startup to grow up, to get into the market and be sustained?
Oof. Well, I would say, as I said earlier, we did a bit of disruptive innovation, not so much on the technology, but on the business model. Like when we started, people were charging for the software, were charging for the documentation, were charging for the hardware. We said if the software is open source, nobody should charge, or free software, sorry. If we got the software for free, we should not charge people for the software. We thought for documentation, what's going to be easy to copy should be Creative Commons. And so we thought the only thing you can charge for is hardware. Right now, the world has transformed since 10 years ago or 11 years ago when we started. Right now, what's happening is that hardware is becoming a commodity. And we're in Korea, and there's a lot of factories. And I think people are risking these things. So that, like when companies like, for example, Google come in and say, oh, we want to make the Google Earth project, and we want to give away Bluetooth beacons. And they make 1 million Bluetooth beacons, and they're giving away for free. They are trashing 2 or 3 small companies making Bluetooth beacons on the way. And because they live from selling them, and then Google can make them for less money and sell and giving them away for free. So hardware is a commodity, and people are trying to go back to charge for the software. And this is a cycle, and we'll probably come back later on. So if you want to start a hardware company, I would say you have to be very careful. because either you have a really clear view on what's going on, and you really innovate on something where you know you have a competitive advantage. Like yesterday night, for example, during the opening here, I was talking to a company that are making Bluetooth sensors for farms. And their value is that they can get very cheap Bluetooth devices.
Right.
At the price I cannot get them, and it doesn't matter if they are from Arduino, I cannot get them for that price. So if you have €5 Bluetooth devices, then of course you're gonna beat anybody else. That's your competitive advantage. But if you don't have that, it's really hard to compete. So we see many companies that start under the paradigm, oh, we're going to make the best content. We're going to make sure. But if your hardware costs 10 times as much as this other one, people will go to the cheap hardware anyway, and they will get your content. So how you're going to capitalize on things is a complex thing.
Then let me get some questions from audience if you have any. Or I have tons of questions for you. If there is not, then I will go more comfortable question for you. What was the most craziest Arduino project you ever saw?
Yeah, I get this a lot. I will go for the. I mean, I like projects that involve complex thinking about stuff and mainly relate to education. And one of the most amazing projects I've seen is the idea of teaching about space technology at high schools and letting the students run experiments in space. And that's made by an American company called NanoSatisfied. And what they do is that they have a kit with an Arduino board and some sensors, and you can check things like temperature, humidity, and so on Earth. But then you can rent a time slot to do the same experiment in space. Right. And they have a satellite in space that has the equivalent to 8 Arduino boards, so you can run the same experiment on distance in space. So that's really cool, like how you can try something on land, and these high school students, all of a sudden, they can transport themselves to this satellite and test the things. To me, that's mind-blowing. That's something that's never thought of. Like when I was a child, I really wanted to be an astronaut. I can't. I have 1,000 allergies. Now I'm overweight, so I will never be an astronaut. I could be 2 astronauts, not just 1. But I mean, now a kid can really think about, trying things out in a way that we couldn't. And I think that's going to transform the way future scientists think about science, because they can start getting trained from a much younger age and get a better understanding of things and so on.
I think when you start this, it must be really hard to bring people beyond the different area to bring in your genre, like artists from technology or technology to artist genre. So what was the most barrier for you when you started the building?
Actually, getting artists interested in technology was very easy because I was part of the art world, and to me, Arduino was built as part of this discourse because there is something in contemporary art that talks about democracy and equalitarianism and access to technology and so on and so forth, and I was part of that discussion. So suddenly I said, oh, you want to make an art installation, you can use this. You don't have money to use this, you can make it yourself, here are the parts. And that was very appealing to artists in general. The really hard thing was to bring engineers on board, because there is the pride of the engineers. Like, no, this board is used by designers and artists, it can be good, And I'm a trained engineer. So to me, one of the biggest successes in my eyes was when my electronics professor told me that in his class, he was using Arduino boards to teach sensor technology to his students. That was like, okay, I gained the engineer world. Like, I got engineers on board. Again, technology gets obsolete over time. So we'll see also how we have set a new standard, but there will be something else that will, make our stuff obsolete. So our role now is to continue to innovate and bring new things. That's what we're doing all the time.
I overheard that you mentioned that Arduino is a new language or tool for artists or engineer.
Yeah.
That's great. So when you started this, it wasn't a formative company, but it became a company and being a sustainable. Then how do you see the future of Arduino and you yourself?
Well, as I said, hardware is becoming a commodity, so we are looking at which is our software strategy for the future, because we've always given software for free, and we take donations from people. Like right now, we're running a Kickstarter project to just support the protocol, for example. So we're going to be trying a lot of different strategies to see what is best for us, because I don't think there is one strategy. Like, there is a lot of hardware companies that they follow the Kickstarter route or crowdsourcing in general. I don't think that's necessarily the only route. In Arduino, we do collaborations with large corporations. Like, we collaborate with Intel, with Samsung, with Microsoft, and so on. And what we do is that we bring our software to their devices so that their users can use the same computing paradigm that our users use. And I think that's a very interesting situation where we can let big corporations pay for the development of things that can then be used in other contexts. So I think that will make us sustainable a lot more than crowdsourcing, for example.
Then what would be unchangeable mission of Arduino for my last question? What would be your unchangeable mission statement for Arduino?
The unchangeable mission? Oof.
Because it must be really different to work with a large-scale company like Intel or Samsung, and you used to work with a small or makers or artists.
Well, you will be surprised because inside large corporations there is people.
Right.
We tend to imagine that large corporations are these fluffy entities, but then all of a sudden, when you cut this like jelly with a knife and you look inside, there is people inside doing work every day. So my relationship with large corporations has been through people that are very interested in open source, in sharing, and so on. And many times what they want is to figure out ways how their company can give away stuff. And so we become a vehicle and an excuse to help these companies do that action. So yeah, I mean, it's not so different in that regard, right? The difference is that when you work with a lot of like small designers and artists, you need to think about how to build these briefs of design that will make tools that are as usable as possible. You think about the common denominator.
Right.
When you work with a large corporation, what you do is to help them thinking about how they can think something else. So it's a different kind of business as well. So yeah.
It's so excited to waiting to what you're going to make in the near future.
Yeah, thank you.
So lastly, would you, let me take one question from our
Yeah,
audience.
sure.
Excuse my ignorance. I don't know much about Arduino. Can you tell me the difference between IoT and Arduino? Is it similar or is it going the same way?
Yeah. It's an interesting question. I think a lot of people ask themselves this one question as well. Well, IoT is a field of technology that looks at how things can be connected to the internet. And IoT can be very broad. Like it can cover from your smartwatch to sensors in your home, right? Arduino is a platform that can be used to produce IoT devices, but it's not necessarily an IoT device per se. So you can see many projects where people design their own connected home and use Arduino boards to control the lights or the temperature or how to open the door. And that will be an IoT project, an Internet of Things project. But and in that case, would also be an Arduino project. But there is, Samsung has something called SmartThings, which is a platform to control devices that in IoT and has nothing to do with Arduino. So there are two different worlds that meet at some point.
Thank you.
Like, if I make a super reduction, you could say Arduino is made of circuit boards that you can use to make your own devices. You make your own robots or to make a watch. And some of those devices can connect to the internet. So if they connect to the internet, they can be IoT devices. That will make a better explanation, I think.
Great. Then before we end up, would you give us some advice or a cheerful message for a Korean hardware startup or innovator?
Yeah, as I said earlier, I had a conversation yesterday night that was very interesting. We were discussing about the fact that both Korean and European engineers, they are very similar. Like they are built on excellence, people that really care about details and making things work and so on. But I think we all fail at pitching. So I would say I think Korean engineering and design companies can sell really well outside Korea. It's a matter of like packaging things right and conveying the right message to users. So I think you have almost everything you need to be a successful endeavor. Yeah.
And try to be delivered more effective or productive way to the market will be the point.
Yeah, I could say, yeah. I mean, I think that the European market is a hard to crack one.
Right.
Of course, the American market is something that everybody wants to have. It's like if you look at Arduino, 50% of the sales of circuit boards are in the United States, and 50% is the rest of the world.
Right.
But also Arduino is something that is copied massively. So I know it sells a lot in China, but not as Arduino.
Right.
So, yep. Thank you very much.
Great. Thank you so much. Thank you so much for your time.
Thank you.
Then we can.
Can you take my seat?